Hello and welcome to week 8 where we're going to be taking the derivative using the chain rule. Well, once we do the chain rule, that's actually going to lead to implicit differentiation and also related rates, but it all is based on the chain rule. So let me start with the basic idea. So if you have a nice simple function like y equals x cubed and you want to take the derivative, then of course you can use the power rule. So you take the 3 in front and multiply, and then subtract 1 from the exponent. And so we would have the derivative equals 3x squared. One other little detail is with y prime, that's the fast way to write it. So that's like my full name is actually Gregory, but everybody calls me Greg. So this is like saying Greg. The full name of it is dy dx. And this is going to become a little more important in a few minutes. But basically this notation is saying that y is the function. So y equals whatever the function is. So y is the name of the function. And then this part down here is saying that x is the variable. All right, now let's continue on with the chain rule. So we already did the derivative of x cubed. Then, what if a function was something like 7x plus 4? Well, the derivative of a constant is 0, so that's going to disappear. And the derivative of a 7x, since derivative tells you slope, the slope of this line is 7. So the derivative equals 7. Or another way to look at that one is x is the same thing as x to the 1. So if you do the power rule, the 1 will go in front and multiply. And then you subtract 1 from the exponent. And this is going to give us x to the 0. And x to the 0 equals a 1. So this really says 1 times 7 times 1. So the answer is 7. All right, now we're going to do the chain rule. So basically, what if you put these two examples together? So my function is going to be just like the first one. It's going to be the cubed function, except I'm now going to take this function, 7x plus 4, and put it in the parentheses. So I'm substituting this function into this function. So we've got y equals parentheses 7x plus 4, and then it's cubed. So you basically need to combine these two problems, and you can only do one at a time. So we'll do the first one. So the 3 goes in front and you multiply, and then subtract 1 from the exponent. So it's going to say y prime equals 3, and you can only do one derivative at a time. So right now I'm doing the derivative of the cube function, so the 7x plus 4 stays the same. And then it's raised to the second power. And then the chain rule says, okay, now it's time to take the derivative of 7x to the 4, which as we saw right here was a 7, and then multiply by that 7. That is the chain rule. So you start on the outside, take the derivative, leave the inside alone. When you're done with this part, then take the derivative of the inside and multiply. So finally, I just want to put this 7 and 3 together and say the final answer is 21, and then 7x plus 4 is squared. And then for some more examples. So I guess I really didn't number the last one, so I'll just call this example number 1. So if we start off y equals e to the 7x. So when you take the derivative of the e function, the answer is exactly the same. So the derivative of the e function is the e function. And then take the derivative of 7x, and that is 7, and then multiply by 7. And we're done. That's the derivative. How about, for example number 2, the natural log of x squared plus 5? Oops, I forgot to say y equals. There we go. So when you have the natural log, the derivative of natural log is 1 divided by x. So whatever is right here, you put the exact same thing right here. And that's how we start this problem. So y prime equals 1 over, and then whatever is in the ln function, then you just put that on the bottom of the fraction. So whatever's in the parentheses, you just put that on the, or in the bottom of the fraction. And then it's this one's turn, and the derivative of x squared is 2x. The derivative of 5 is 0, so the derivative is 2x plus 0, or just 2x. And then I would just rewrite this one because on the top we have 2x times 1. So that's going to be a 2x on top and an x squared plus 5 on the bottom. And then it's finished. I guess I should have circled my answer over here also. All right, next up, what about the square root function? So for example number 3, how about the square root of x cubed plus x? Well, when you take the derivative of the square root function, you could rewrite it as the 1/2 power and then do the power rule, but it's better to just remember the derivative of the square root function is 1 over 2 times that square root function. And much like with the natural log, whatever's right here, the exact same thing goes right here. So whatever's inside of the square root, you put the exact same thing right here. So for this one, it's going to be 1 over 2 times, and then basically you just recopy this square root, and that goes on the bottom. Next, the chain rule says now take the derivative of this x cubed plus x. Well, when you do the power rule on the x cubed, that's going to give you 3x squared. When I multiply by just one thing, I don't really need to use parentheses, but this is going to be more than one thing, so I really should use parentheses right here. And then derivative of x is just a 1. Sort of like earlier when I wrote it to the 1 power, x to the 1 power, and then you do the power rule, it's going to leave you 1 times x to the 0, and 1 times 1 is 1. Oops, I wrote an x. And it's in pen, so I can't erase it. Here we go. Just make it a big old 1. There we go. And then finally, I could rewrite this as, on the top, there is 3x squared plus 1. And on the bottom, there's 2 and the square root of x cubed plus x. All right. Next, so all of the rules for derivatives can be used in different combinations. So for example, number 4, how about if it's a product? And I've used y a bunch of times, I'll change over to f of x. So how about if f of x equals x squared times x minus 10 to the 5th? So this is a product of the x squared and the x minus 10 raised to the 5th function. So that means use the product rule. And the product rule goes, if you're taking the derivative of a times b, then take the derivative of one of them at a time. So you take the derivative of a, and then just copy down the b, plus you just copy down the a, and then take the derivative of b. Now let's use the product rule on this one. So this one's going to say f prime equals, so take the derivative of the first one, and the derivative of x squared is going to be 2x. And then just copy this one down as it is, x minus 10 to the 5th. And then plus, this time just copy down the first function, x squared. And now take the derivative of this one. So that means that the 5 goes in front, and then x minus 10, subtract 1 from the exponent, and so there's the derivative of this. And then the chain rule would say, now you need to take the derivative of what's inside the parentheses. Well, the derivative of x is 1, so multiply by 1. And with this one, I would like to clean it up a little bit because I can see that there's an x in each one of these, and also there's an x minus 10. So I could factor out an x and also an x minus 10. And the rule for factoring out is whatever's the smallest exponent, that's how much you can factor out. It's sort of like if you're going to borrow $4, well, this one could give you $4. This one could give you more, but this one is only going to be able to contribute 4. So it's to the fourth. And the same thing out of the x's, there's only one x here that can be taken out. There are two x's in this one, but for this one, only one x can be taken out. And then just to emphasize that I factored those out, I like to use square brackets and see what's left. So this x is gone, the 2 is still there, and I took out 4 of these, which means one of them remains, and then go to the plus, and one of these x's got factored out, but one remains, and the 5 did not get factored out, so 5x remains. And then all of these got factored out, so now we're done with the factoring. And one last little bit of simplification. The x is fine, the x minus 10 to the fourth is fine, and then when you distribute, this is going to be 2x, and this is 5x, so that's a grand total of 7x. And then I switch back to round parentheses to say this is going to be my final answer. And then when you distribute the 2, that gives us negative 20. And then very soon we'll be taking derivatives and setting them equal to 0. And at that point, because we already did the factoring, you'd set this one equal to 0, you'd set this one equal to 0, and you'd set this one equal to 0. Then, for example, 5, the function will be the cube root of 3x minus 1, and then not only find the derivative, but at the end, plug in 0 for x. So with the square root, we have this shortcut right here. With the cube root, we do not have a shortcut. So the first thing I need to do is rewrite this one. For a cube root, you can rewrite that as a 1/3 power. So just take the whole thing in parentheses, 3x minus 1, and then raise it to the 1/3 power. And now do the power rule. So the 1/3, you bring it in front and multiply, and then subtract 1 from the exponent. So the derivative is going to be 1/3, and then leave the inside part alone for now. And then 1/3 minus 1 is going to be negative 2/3. Or if you want to use a calculator, you can go 1/3 minus 1, and then just use the math key to see what the fraction is. So just hit enter twice, and it says that it's negative 2/3. So this exponent is negative 2/3. And then for the chain rule, when you take the derivative of the inside part, the derivative of 3x will be 3, so multiply by 3. And I should simplify. For 1, I don't like to use negative exponents, so I'm going to fix that problem. Also, this 3 on the bottom will cancel this 3 on the top. And then to eliminate this negative exponent, then just invert it or put the 3x minus 1 to the positive 2/3 on the bottom of a fraction, and that gets rid of the negative exponent. And then the last thing is substitute in a 0 for x. So put a 0 right here, So the derivative, when I plug in 0, will be 1 over 3 times 0 minus 1 to the 2/3 power. And so this is just 0. So really I need to know what is negative 1 raised to the 2/3. So it's really just 1 over a negative 1 to the 2/3. And let's see if the calculator can help us out with that one. So if you have 1 divided by, and then I do need to put parentheses, and I do need to make sure I use this for the negative. And then just use this little up arrow for the exponent, 2/3 power. And it turns out the answer is a nice simple 1. That's because this means cube root, and the cube root of negative 1 is negative 1, and then you have to square that, and when you square a negative 1, it's a positive 1. Okay, then on to implicit differentiation. So this is basically just a continuation of the chain rule. But it's called implicit not implicity. That was silly. Implicit differentiation. So when I was writing that, I was thinking of the root word. The root word is to imply. So it implies that we're taking a derivative. So implicit differentiation. And let me start with something that we already know. Like if you have a 7x plus 1 raised to the 5th power. So this is just the chain rule. So take the derivative, do the power rule. So it's going to be like this after you do the power rule. And the chain rule says this part has to stay the same. Basically, each function has to wait its turn because you can only do one derivative at a time. And then I take the derivative of this 7x plus 1, which is a 7, I put it on the outside. All right, that's the chain rule. Then implicit differentiation goes like this. So y equals, and I'm even going to do basically the same problem, something to the 5th. But then suppose that the something in here is, you guessed it, a smiley face. Then take the derivative. Well, it's going to look just like this. So first of all, you start with the power rule. The derivative is going to be 5 something to the 4th. And the smiley face has to wait its turn. It's not your turn yet, buddy. Just stay there nice and happy. And then like right here, we took the derivative and we put it out here. That's the chain rule. Well, you do the same thing, but I don't know what the derivative of a smiley face is because I don't even know what math function that is. So what I do is I just say, okay, put the derivative of smiley face out here. And if somebody ever tells me that smiley face equals a 7x plus 1, then I know that on the outside goes its derivative. So you leave the smiley face alone, and then afterwards the chain rule says then take the derivative. So basically we're implying that smiley face is some function of x, and if we don't know it, we just put smiley face. So if, put a nice line right here and then I can do the next one. So if y was equal to u to the 7th, and it's implied that u is a function of x, but we don't know what it is. So basically I'm just replacing smiley face with a u. So then find dy dx. So at the beginning I said y prime is the shortcut way to say it. The longer way to say it is dy dx. And this is saying y is the function. Yep, y equals the function. This is implying that x is the variable, even though we don't see an x in there. And we do it just like this. So dy dx, or y prime, the derivative equals, do the power rule. So the 7 goes in front, you multiply, subtract 1, there we go. And then you take the derivative of the u and you put it right there. Now if somebody tells me what u equals, I'll substitute it right there and I'll put its derivative right there. But since nobody told me what the u equals, then I just put u prime right there. That's implicit differentiation. So for example number 6, if you have y equals the natural log of u. So taking the derivative of the natural log is very easy. That's just 1 divided by whatever's in the parentheses. And then the chain rule would say take the derivative of u, and since I don't know what u is equal to, then I just say, all right, take the derivative, and there you go. You could literally leave the answer like this, but the top is saying 1 times u prime, so you could simplify it a little bit and go it's u prime over u. All right, next up, for example number 7. Suppose that y is equal to the square root of w. Find dy dx. So this is the part that's implying that this is a function of x, even though we don't know what w is equal to. So for taking the derivative of the square root, like I said a little bit earlier, it's best and easiest to use the shortcut. The derivative is 1 over 2 times that same square root. And then take the derivative of the w, and since I don't know what w equals, I just put it like this. And like with the last one, I can simplify because the top has w prime times 1, so that's just w prime. And then you can leave a square root on the bottom. If anybody ever told you you cannot leave it on the bottom, then just ignore them. Now what I'm going to do is the exact same problem. Example number 7 again. So start with the same problem. Y equals the square root of w. And I will end up with the same answer, but I'm going to do it in a slightly different way. So what I'm going to do is square both sides. Because what that does, on the right side, the square and square root will cancel. So that means that the right side just has a w, that makes it simpler. And the left side just has y squared. Now take the derivative on each side. So on this side, I'm going to need to do the power rule. So the 2 goes in front, multiply, and then subtract 1 from the exponent. So that's going to be 2 times y. And for the derivative, all I've done is the square part. I never took the derivative of y. So that is the implicit differentiation, or also known as the chain rule. You also have to take the derivative of y, but you can only do one derivative at a time. So there's the derivative of the square, there's the derivative of the y. And on the right side, I just say take the derivative of w. Now I want to solve for the y prime, so divide both sides by 2y. And then after these cancel, I get y prime equals w prime on top and then 2y on the bottom. And if you go back to this problem and ignore the red part, it says y is equal to the square root of w. So I can replace this y with the square root of w. And then if you compare that to the other way that I did it, they both have the same answer. One of the great things about math is you can do things in different ways and come up with the exact same answer. Now, for the reason that I did it this way, you might be thinking, well, that's just a longer way to do it. Why would you do it the longer way instead of a shorter way? Well, that brings us to our next part. So for example number 8, suppose that the function is x squared plus y squared equals 1. And the directions are find dy dx, or in other words, y prime. So the idea of the implicit differentiation is also here, it's implying that y is a function of x, even though it's not written as y equals. You could do that, but you can also just go ahead and take the derivative. So we are taking the derivative with respect to x. So watch this one. If you take the derivative of x squared, you put the 2 in front, you subtract 1 from the exponent, and you get 2x. And then technically the chain rule says you also need to take the derivative of x. But when you're taking the derivative with respect to x, that's going to say take the derivative of x with respect to x. And dx divided by dx equals 1. Or in other words, the derivative of x equals a 1. So multiply by a 1. Then go on to the y squared, and the derivative will be 2y. And then the chain rule says you need to take the derivative of the y, so that's going to be y prime. And on the right side, the derivative of a 1 equals 0. So now we're done with the calculus part. Now I just need to do algebra to solve for dy dx, which I'm just writing the fast way to write it, the y prime. So we need to solve for this y prime. I'll begin by subtracting 2x from both sides. And then this is still on the left side. And the right side has negative 2x. And then the next thing to do is divide by 2y. And after you cancel, it's going to be y prime equals, and I can even cancel the 2's on the right side. So it's going to leave negative x over y. And we're then done. If they gave us some numbers to plug in, we could do that, but we're actually going to do that on the next one. Now what this means is this, if you graph this, it's a circle and the radius is 1. So it's a nice, perfectly round circle like this, which would touch all of the axes at either 1 or negative 1. So that's a circle. And then if you were given some point, like I said, if we have some numbers to plug in, then this is the slope of the tangent line. So the derivative always gives you the slope of the tangent line, at least when you're talking about x's and y's. And so then if you had some particular point, then basically we would be finding the slope of this line right here. And on to the next one. So that was number 8. This must be number 9. So for example number 9, what if you had x squared plus y squared equals 1? And then you go, uh-oh, I think he's messing up because he just did that example. Oh, yes, but we're going to do it again. So then the directions are find dy dt, and there's the difference. So we can start with the same problem, but this is asking for the derivative with respect to t. And there is no t in the problem, but you can still find the derivative with respect to t. So the rest of the directions go if dx dt equals 2 at, and then the specific point is the square root of 2 over 2, comma, the square root of 2 over 2. So we basically go through the same work as this, except this right here is not going to be a 1 because when I did this part, I got dx over dx equals a 1. Well, in this step, it's going to say dx over dt, and then that equals x prime. So basically this is shorthand for y prime, and then this is shorthand for x prime. So on this side, when I take the derivative, it's going to be 2x because of the power rule. And then take the derivative of x, and because we're taking the derivative of x with respect to t, that means I get an x prime. So then it's going to be times x prime. And for the y squared, it's going to look the same except with the letters y instead of x. And on the right side, the derivative of 1 equals 0. So derivatives also talk about how fast things are moving. So this is saying that in the x direction, either left or right, this thing is moving at 2 units per second. So maybe it's like 2 feet per second or something like that. So this is actually talking about motion. And this is saying that it's moving to the right because it's a positive. And then this would be talking about how fast it's going up or going down. So basically I need to just do the same algebra that I did. So subtract 2x, x prime from both sides. The left side has the 2y, y prime. The right side has the 2 negative 2x, x prime. And like with the last one, divide by 2y and divide by 2y. And so once these cancel, I get y prime equals, and these 2's will cancel, but nothing else will cancel. So it's negative x times x prime over y. Now I just need to substitute in the numbers. So for x prime, substitute a 2, so that one's going to become a 2. This is the x and this is the y. So y prime equals negative, and then I'm just going to make a big fraction out of it. So this x needs to be the square root of 2 over 2. And then x prime goes right here, 2. And then the y value goes on the bottom. And then because these two things are the same on the top and the bottom of a fraction, they actually cancel each other out. And so y prime equals a negative 2. So the y direction means either up or down. So this means it's going down. And if you go back to the graph, so it's a circle. It's the same circle that I just drew earlier, where this is 1, 1, negative 1, negative 1. And when we did the dy dx, so when we did the dy dx, it's talking about slope. So if you draw a tangent line, then the derivative would be telling us the slope of this line. But when you take the derivative with respect to t, that means, so this point right here, so that means that an object is going around the circle, and when it gets to this point, this is the x direction and it's positive, so that means it's going to the right, and this is negative, so it's going down. So if the point is right here and it's going to the right and down, that means it's going this direction. So it's actually going clockwise around the circle. And this is how fast, so as I move my pen from here to here, I do have to move it down, and this is how fast it's going down. So the units could be something like in feet per second, or miles per hour, or something like that. But basically it's telling us the object is going this direction. And then for the last idea of this week, related rates. So the most important idea of this section is the chain rule. And then the chain rule leads us to implicit differentiation. And then related rates is just more of the same. The only difference is you might have some type of word problem or something like that you need to set up yourself. You need to set up the equation yourself. So for example, number 10, a 10-foot long pole leans against a wall. But then the floor has just been mopped and it's all wet and the pole starts to slide out. The bottom of the pole slides out at, let's go with 2 feet per second. So here's a wall, here's the ground, and then there's a pole leaning against it. And when you have a word problem and you go to make a picture, you need to use variables if there are things that are gonna change. With this being a 10-foot pole, nobody's gonna come and chop a foot off of it or break it in half or something like that. So that's not gonna change. So that means I can leave this as a 10-foot pole. But the distance here on the ground, that needs to be a variable, so I'll call it x. And as the pole moves out this way, as it slides out this way, then the top is going to slide down, so this needs to be a variable y. And then find dy dt, or in other words, how fast this is sliding down when the x equals 3 feet. So basically, here's 1 foot, 2 feet, 3 feet. When the x gets out to be 3 feet, then how fast is this part sliding down? So this is a right triangle, which means we can use the Pythagorean theorem. And the Pythagorean theorem says this squared plus this squared equals this squared. So the equation is going to be x squared plus y squared equals the 10 squared. And just like with the last one, take the derivative, and the derivative is with respect to t. So when I take the derivative, it's going to be 2x, and then take the derivative of x, which you can either write as dx dt or the shortcut x prime. And then there would be 2y times y prime. And then this is the number 100, and the derivative of that is 0. So when I did this twice before, I went ahead and solved for y prime and then plugged in the numbers. You can do it the other way around. So you would have the function, you would take the derivative, and then you would take a break and go over here and do algebra. So it says that when x equals 3, so this algebra part is not going to use the derivative, which is what this is. It's just going to use the algebra part. So if you go back to the equation, x squared plus y squared equals 10 squared, or in other words, equals 100. And if you plug in x equals 3, so that's going to be 3 squared plus y squared equals 100. And I happen to know that 3 squared equals 9, so subtract 9 from both sides. And y squared equals 100 minus 9 is 91. And then take the square root of both sides, which looks especially nice if you have a red pen. And so y is equal to the square root of 91. So now I can take that and plug it in for that y. I can take this 3 and plug it in for that x. And then this is the bottom. So that means it's talking about the bottom. It's talking about x. So in other words, it's saying that x prime equals a 2. So this is going to be a 2. This will be the 3 for x. And this will be the square root of 91 that we got over here for the y. So this is going to say 2 times x, and then times x prime, and then plus 2 times the square root of 91 times y prime. And then it still equals 0. So now I just need to solve for y. So this is going to be 2 times 3 is 6, times another 2 is 12, so subtract 12 from both sides. And we're left with 2 and the square root of 91 times y prime. And on the right side, we've got a negative 12. And just 2 more steps. Divide both sides by 2 times the square root of 91. And the last step is just put that in the calculator and see what that equals, because I'm not doing the square root of 91 in my head. Negative 12 divided by, and because this has 2 things, I do need to use parentheses. So parentheses and then 2 and the square root of 91. There we go. So then it's negative 0.629. So it equals negative 0.629, and then the units would be the same as this, feet per second. And then the negative makes sense to me because if somebody's pulling the bottom out, that means the top is going down. And then that's what the negative means. So negative means going down. Positive would be if it was going up. And we do have one more example. Example number 11. And I got this one from my math lab homework. Suppose that you drop a rock or a pebble or something like that. So there's this lake that's the water's all nice and calm, and then you drop a rock or a pebble. So basically when you drop it, then there's going to be waves that go out in circles. So basically, I could just say, all right, at one point, here's where I dropped it, and at one point, the outer wave is going to be like this. And then I would need to know the radius of that. So then how fast is the circumference? Of the circle or the circular wave growing if the radius is changing by, let's say, 2 inches per second when the radius equals 5 inches. One thing to pay attention to in word problems is that the units are the same. So this one says inches and this one says inches. So if this had said feet, then I would need to change it to inches, because everything needs to be in inches or everything needs to be in feet. Whatever the units are, they have to be consistent. Here, inches and inches, so you don't have to worry about it. So then, circumference. So circumference means if you measure all the way around the circle, so you've got like a measuring stick or something like that, and you measure all the way around the circle, then How long is that red circle right there? Of course, it would be easier rather than going around the circle if you could just cut it and then open it up and make a line. But since it's made of water, it's going to be very hard to do. So we'll just have to use the picture of it. So the formula for circumference. Circumference goes take 2 pi times the radius, and we're done. That's the circumference. Now take the derivative. So on the left side, I would say the derivative, which is exactly what this is saying, because this is saying how fast. So this is saying what's the derivative of the c. So that's what we're solving for. And 2 pi is just a number, so it can just stay there. Well, I take the derivative of r, and because it's just an r, its derivative is r prime. I'm getting sort of long with my primes there. All right, then we just need to plug in the numbers. So this is saying r prime equals 2, and notice in the derivative, there is no r left. So this actually doesn't even matter. So this was actually extra information I didn't even need. So c prime equals 2 pi, and then it's given that r prime equals 2, so I can just substitute that in. And then on the homework, if they asked for an exact answer, you would just multiply 2 times 2, so that's 4 pi. But when you have word problems, you really should give the decimal answer. So 4 pi as a decimal is 12.566, and circumference is a length, so that would be in inches per second. Inches per second. All right, so right after this, I'm going to make the video with the homework examples. Hopefully you check out that one also.